Hey, what's up, Algebra 2? It's Ryan. Today we're going to be going over completing the square. So, completing the square is essentially another way to solve a quadratic. So, thus far in this unit, we've gone over regular factoring, we've gone over the quadratic formula, we're going to go over completing the square. We're essentially just giving you a bunch of different strategies to solve quadratics. So you have a bunch of different strategies on your at your disposal when you take a test or when you take the SAT. Now, also completing the square is going to be super important when we're graphing or when you want to switch in between different forms of quadratics. So if you remember, in our very first lecture on quadratics and graphing quadratics, we had three forms, right? We had standard form, something that looks like this, where we have an ax squared plus bx plus c, right? We had a vertex form where we had a times x minus h squared plus k. And we also had an intercept form, something like this. Don't forget that a. Now, completing the square is going to be super helpful when we're going from standard form to vertex form. And sometimes you'll want to do that because when you're graphing, you may find it easier to graph a quadratic that's already in vertex form, and completing the square can help you with that. Okay, so I've done a lot of talking. Let's actually get into the material now. Okay, so we have this example 1 where we're asked to find the values of c that make the expression a perfect square trinomial. Then write the expression as a square of a binomial. So I'm going to work backwards. We want to write the expression as the square of a binomial. That means we have something like a x minus q, or x plus 2, or plus q, doesn't matter, squared, something along those lines. So essentially, right, when we square something, it's just multiplying by itself. So I'm going to write it out like this. And now what we want to do, and I'll go over exactly how to complete a square in example 2. I'm just going to sort of give you an introduction. But we're going to FOIL this. So we want to do x times x. We get x squared. Now we do q times x, which is qx, 1qx. And then we're going to add q times x again. So I'm just going to do this in my head because I don't really want to write this out right now. But we'd have qx plus qx, which is just 2qx, right? And then we have q times q, which is q squared. So you'll notice here that we have this, our coefficient of our b term is this 2q, right? So I'm going to write this out. I'm going to say 2q equals b. Or now I'm going to divide by 2, and I'm going to say q equals b over 2. And so if you see, we had q here. I'm going to plug this b over 2 in, which is equal to q for our q up here, because we have, let's do something here. We have this q, and we have this q. So I'm just going to sub this b of 2, or b over 2 in there. And we'll get something that looks like x plus b over 2 squared. Okay? And now, when we FOIL that out, right, when we go from this step to that step, I know it's getting kind of messy. Right now, actually, we're just going over how to complete the square. Right now, it's not even an introduction. But when we go from this first step to FOILing it out and getting x squared plus 2qx plus q squared, anytime I see q, I'm going to plug in b over 2, because we just said they're equal. So I'm going to say x squared plus 2 times b over 2, which is just b, x plus b over 2 squared. Okay, and this is going to give us a perfect square trinomial, which essentially means, right, we can write it like this, where we have x plus something in parentheses, a binomial squared. So in this case, what's our value of b? Our value of b is -8. b equals -8. So b over 2 equals -4. Now, you'll notice here this term, I'm going to choose a different color. Yeah, let's go red. Okay, this term is equal to our c value. So c equals b over 2 squared. Okay, so I'm going to plug in b over 2, which is -4. -4 squared is going to be 16. So our value of c is 16. And I'm just going to write out the entire trinomial, the perfect square trinomial. Something like this. And then the square of a binomial would be plugging in this b over 2 for q. So something that looks like that. We said b over 2 is -4, so I'm going to say x plus -4, which is just x minus 4 squared. Okay, hopefully, if it's a little hard right now, we'll be going over a bunch of practice problems throughout this lecture. So don't be discouraged, but yeah, let's just keep on pushing on, and I'll keep on explaining this. Okay, so again, we want to find the value of b over 2. Well, first of all, our b value in this case is 11. I'm going to write this off to the side. b equals 11. So b over 2 equals 5.5. Right? So our c value, our value of c, is going to be b over 2 squared. So that means 5.5 squared. Now I'm actually going to say this is 11 over 2. And I'm just going to say c is equal to 121 over 4. Should I say that? Or should it? You know what? I'm just going to find the value of 5.5 squared. 1 second, let me get my calculator out. 5.5 squared. That's going to be 30.25. So we get 30.25 is our value of c. So we're going to say x squared plus 11x plus 30.25. Okay, sorry, I went kind of over. And now the square of a binomial, that would be this. So we just plug in our value for b over 2, and that's going to be 5.5 or 11 over 2. So our square of our binomial is going to be x plus 5.5 squared. Okay, great. Now let's move on to example 2. So solving a quadratic by completing the square. So essentially, I just sort of taught you, if you're confused on this part, what we did here, I'd go back in the video and watch that, because it's very important you understand how we derived this x plus b over 2 squared in this standard form version. Okay, but now we're gonna actually use that to solve a quadratic. So let's essentially what we want to do when we're solving a quadratic is by completing the square, we want to have our left side be a perfect square trinomial. So something that looks like this. Okay? So what we're first going to do is we're going to find our b value. Our b value is 6. So our b over 2 is going to be equal to 3. Okay? Now we want our c value to be, right? We said c equals b over 2 squared. So b over 2 is 3. 3 squared is going to be 9. So we want our c value to be 9. So I'm going to do this, write this down here. Eventually, we want to get to the point where we have x squared plus 6x plus 9. We want our c value to be 9. But in order to get there, right now we're at x squared plus 6x minus 8 equals 0. We have to add what to get from negative 8 to positive 9? Well, we have to add 17. So we're going to do plus 17, plus 17. And this is going to make our our right side equal to 17. So we're adding 17 to both sides. Now this is our perfect square trinomial, but we want to sort of make it into a square of a binomial, something that looks more like this. So we're going to say x plus b over 2, and b over 2 is 3, so x plus 3 squared equals 17. Now at this point, we're just going to take the square root of both sides, and that's going to give us x plus 3 equals plus or minus root 17. And then we're just going to move this 3 over. So we're going to subtract 3 from both sides. That's going to give us x equals negative 3 plus or minus root 17. That's going to be our answer. Okay? Oh, and just keep in mind, once you get this root 17 or whatever number, try to simplify. In this case, it's a prime number. We can't do anything with it. But if you can, definitely simplify. Try to factor out something. Okay, so I showed you how to solve. Now I want you to try on your own 2a and 2b. Okay, so and I did not explain this yet, but in this case, our a value is 1. And if we look at the steps of solving or completing the square, you'll notice that we have to make sure the coefficient of x squared is 1. We have to make sure our a value is 1. So sometimes, otherwise we just can't use completing the square. So in the case where our a value is not 1, in this case it's 5, we need to factor out of 5. Okay? So I'm going to do that here. We factor out of 5, we get x squared minus 2x plus 6 equals 0. Okay? Now, here, since it's an equation, I can technically just divide both sides by 5, and we get 0 divided by 5, so I can take that out. So that's why I'm going to cross that out. But when you're graphing, you don't want to do that. I believe we'll go over that in a second. Yeah, when we're creating the actual equation, you want to keep that 5, because that 5 is important. Okay, anyway, so we have x squared minus 2x plus 6 equals 0. Again, we want to complete the square. So first thing we want to do, what's our b value? That's negative 2. Our b over 2 is equal to negative 1. Sorry, that's like a weird 2. And so our b over 2 squared, which is equal to c, is going to be negative 1 squared, which is 1. Okay? Great. Now let's do x squared minus 2x. And then we want to get from positive 6 to 1. Okay? Let me just make sure I'm doing this correctly. Yep. So we want to get from positive 6 to 1. So what I'm going to do is I'm going to do 6, 0. I'm going to subtract 5 from both sides. Okay? And that's going to give us x squared minus 2x plus 1 equals negative 5. Okay? And now we have this perfect square trinomial, so I'm going to rewrite this as x plus b over 2. We said b over 2 is negative 1. So x minus 1 squared equals negative 5. And now we take the square root of both sides. Let's see. And then we get a value of x minus 1 equals plus or minus root negative 5, which I'm going to say is plus or minus I root 5. Okay? Because we said I is equal to the square root of negative 1, so I can just take that out. Now, if we move over this 1, we want to just get x by itself. So I'm going to add 1 to both sides. We get x equals 1 plus or minus I root 5. Now, one thing I'll say is when we're graphing this, we have I. And so our solution, x equals 1 plus or minus I root 5, is going to be imaginary, of course, because I is imaginary. And what I would do, just to make sure, in some of these things, once you get an answer, check if it logically makes sense. So in this case, if I look at this quadratic and I think about graphing it, okay, I know that our y-intercept in standard form is just going to be our c value, so it's going to be 30 something up here, it's going to be positive. And I know that my a value is positive, so that means it's going to open up. So that means, and this is a rough sketch, it's going to be real skinny, but the main point is our y-intercept is going to be positive and our parabola is going to open up. That means it never crosses the x-axis, and that's why we'll have an imaginary solution. Okay, in this case, let's do 3a together. Okay, so here we want to get our a value right now is 4. We don't want that. We want our a value to be 1. So we're going to divide both sides by 4. And that's going to give us x squared minus x minus 1/2 equals, and 0 over 4 is just 0. Now, we want to find what our b value is. So our b value right now is negative 1, since we have negative 1x. So our b over 2 is negative 1/2. So our c value, which is b over 2 squared, is going to be negative 1/2 squared, Well, it does not really matter that it's negative because the negative times the negative is a positive. So what's 1/2 squared? Well, that's going to be, because I'm just going to write this out because sometimes people can get tripped up on it. We do 1 times 1, that's 1. 2 times 2, that's 4. So it's going to be 1/4. So our C value is going to be 1/4. So we want to ask ourselves, what value must we add to negative 1/2 to get to positive 1/4? Well, that's going to be 3/4. Okay. Now I'm just going to rewrite this left side. We have x squared minus x plus 1/4 equals 3/4. And now I can just rewrite this as a square of a binomial where it's x plus b over 2, and we said b over 2 is negative 1/2 squared equals 3/4. If I take the square root of both sides, then we'll get something along the lines of, you get something along the lines of x minus 1/2 equals plus or minus root 3 over 4, which this is the same as that. And we know that from our exponent rules, radical rules, whatever. And root 4 is just going to be equal to 2. So I'm going to rewrite this as plus or minus root 3 over 2. So x, when we add 1/2 to both sides, x will equal 1/2 plus or minus root 3 over 2. And since they both have the same denominator, we can make this a little bit more visually appealing and say 1 plus or minus root 3 over 2 is our solution to our solution. Okay, perfect. Now let's go on to rewriting equations in vertex form. So in the very beginning of this lecture, I talked about how completing the square is going to be helpful going from standard form to vertex form, right, which we see here. So what we want to do is complete the square of our quadratic in standard form. And then I'll show you how that leads to an equation now in vertex form. So first, as with always, what's our b value? It's going to be 6. B over 2 is going to be equal to 3. So c, which is equal to b over 2 squared, equals 3 squared, which is 9. So I somehow, first we look at this, we say our a value is 1, so we don't need to do anything right now. Okay, that should always be our first step. Okay, sorry, I did not say that out loud. Okay, so now we want to add something to y so that we can have x squared plus 6x plus 9. So how do we get from 16 to 9? Well, we have to subtract 7. And now our equation is going to look something like y minus 7 equals x squared plus 6x plus 9. And this is a perfect square trinomial, so we can say y minus 7 equals x plus 3 squared. And now I can just isolate y by adding 7 to both sides. We'll get y equals x plus 3 squared plus 7. That's going to be our answer. You see, that wasn't that bad, right? Okay, let's do number 3. Okay, because number 3, we have an a value that is not 1. So we first need to factor a 3 out. So that's going to give us x squared. Negative 12 divided by 3 is going to be negative 4x. Then we have plus 1. When we factor out a 3, that's just going to be 1/3. Okay, so we still, up here, we had an equation. We had an equation where we're solving for the values of x, and we see that it's equal to 0. And since it's equal to 0 when we factor something out, 0 divided by whatever we're factoring out is just going to stay 0. So we don't really have to, we don't care about that as much. But here, we're actually graphing it. Here, our a value is of significance because that's sort of determining how vertically stretched or compressed our function is. So we want to keep this 3 on the outside, but we still want to manipulate this, what's inside the parenthesis. Okay, so in this case, we first want to think about what's our b value within the parentheses. Well, I'm gonna write this off to the side. Our b value is negative 4, so our b over 2 is equal to negative 2. Now our c value, which as I said before, is b over 2 squared, so that's negative 2 squared, which is positive 4. So we somehow we want to get from positive 1/3 to positive 4. Okay, and that's positive 4 inside the parentheses, okay? So, and that's, well, we'll talk about that in a second. So we have y equals 3 times x squared minus 4x plus 1/3. Now, what do we have to add? Maybe we do this out. What do we'll say, not x, we'll say, okay, let's do g. G wasn't the best choice, but it doesn't matter. G plus 1/3 equals 4. Well, g would have to be 3 2/3, which is just going to be the same as 11/3. So I'm going to say plus 11/3. Now, I'm adding this 11/3 inside the parentheses. I'm still multiplying that 11/3 by 3. So I can't just add 11/3 to both sides. I have to add 11/3 times 3 to both sides. Well, 11/3 is times 3. The 3's are just going to cancel out. We're going to have to add 11 to both sides. Okay? And that's something you definitely want to be mindful of, because it's easy to make a small little mistake by just adding 11/3 to both sides. So now we have y plus 11 equals 3 times x squared minus 4x plus 4. Now I'm just going to rewrite that parentheses as a square of a binomial, where it's x plus b over 2, and our b over 2 value is -2, so I'm going to say x minus 2 squared. Move this 11 over by subtracting, and we get an equation that looks like this. That wasn't the best circle. But you know what? Let's just do this in blue. Feeling very, colorful today. Okay, and from here, why you might want to have this in vertex form, right? It's called vertex form for a reason. You can easily see our vertex is going to be HK, right? Or let me write this out. I don't want to get too off track. But our vertex is HK, which is just going to be, in our case, it's going to be not negative. Ooh, I almost made the mistake. It's going to be +2 because we already have a negative in our formula, -11. And then from there, it might be easier to graph certain things for you. And if you have your vertex by completing the square, and you combine that with the information you have from your quadratic in standard form, you can easily find your y-intercept. There you have 2 points. You plug in another to whichever equation you want, and yeah. Okay, so completing the square, historically, it's a topic that some students struggle on. So I really want to stress the importance of, if you don't fully understand this, or if you aren't 100% confident in your abilities, that when this shows up on a test, you can do this no problem, please go to your teacher, go to the tutoring center, use me as a resource. That's why I'm here. You can email me, stop me in the hall, do whatever. I'm here to help. Use your classmates. If one thing, and this is not just for math, this is for any class, there's going to be some smart kids in your class. Go, if you have a question, use them as a resource, okay? So lean on your peers, lean on your teachers, lean on me, lean on the tutoring center, and you can also lean on the internet. There's so many resources out there. Use them. Learn it, and then keep on getting reps. Do a bunch of practice problems until you've mastered it. Okay, great. Thank you. Have a good day. See ya.